Okay, well, somehow I screwed that up, but I didn't record, but anyhow. Here is the graph of y equals a b to the x. Plus k. That's the white graph. We can see that this is going to level off at about this level, so we're going to estimate, here's our horizontal asymptote where y equals k. And then what do we do? Well, k is a negative number, so it's indicated by a downward arrow of this length. We add k to the y value of every point, meaning we take that arrow and, take every point and use that arrow to determine the new points. And that'll give us the graph of y equals ab to the x. Then we can immediately estimate y equals a. So where x equals 0. X equals 0, b to the 0 is 1, so y equals a. So y equals a on this line. A is negative. We're down below the axis. So a is a negative number. What do we do next? Well, having sketched this green line, we sketch its reflection through the x-axis. And that's going to be y equals the absolute value of a times b to the x. Y absolute value of a, well, it's just going to be, I could call it negative a, but that negative sign would be confusing. Okay, so we're just going to do absolute value because everything's going to work out just fine. Okay, well then, if x equals 0, then y equals absolute value of a on this line. So right here is your line where y equals absolute value of a, right where the y-intercept of the purple line is, or purple curve. Okay. So now we've got our value of a. If we have a scale here, we can measure it. So what do we do next? Well, we want to find the value of b. Okay. We don't have b. We have k. We have a. We still need to find b. We find the line x equals 1. And I commented sometimes scale is such that we can't use 1. We might have to use 1 million or something, and depending on the x scale of the graph. Because x equals 1, even difference of 1 would be invisible in a graph in scale of millions. So you have to be a little careful about that. And you can adapt that, but I'm not going to make you do that anywhere in this course, unless I put an extra credit problem exam. Okay? Just to make you glad Christmas is coming. Okay, so what we do then is we draw the x equals 1 line, and we know now that the x or the y value of this point is going to be what? Well, this is the curve y equals absolute value of a b to the x. If x equals 1, that's just absolute value of a times b. So right here, this line is the line y equals absolute value of a times b. A horizontal line through the intersection of the vertical line x equals 1 with the curve. We need to understand in as much detail as possible why that's true, because it makes you much better at thinking. Okay, and you need to be if you're going to take additional math courses. Well, now we know that the absolute value of a is this big, and the absolute value of a times b is this big. So the question I pose is, first of all, what's bigger, the absolute value of a or the absolute value of a times b? Okay, so the answer was, well, absolute value of a is bigger than the absolute value of a times b, right? Then I asked, okay, so is b bigger than 1 or less than 1? And I didn't get a good answer. And it's not surprising. Yeah, so please don't hang your head in shame or anything. You'll beat it against the wall a couple of times, but gently. Okay, seriously. These put calculators in kids' hands at the age of my 10-year-old grandson and younger, and they never developed number sense. They never developed the idea that you would have to multiply this by a number less than 1 to get this, because this is less than this. Okay. Yeah, what portion is this of this? it looks like maybe a little less than a half, doesn't it? If this is about a half of this, then it better multiply A by half. Now, I don't think it's a half, I think it's 0.4. So we're gonna go with what I think. Not that I dismiss what you think, because you're pretty good at doing these estimates. Okay, but then just that whole idea. Okay, so I'll get off my soapbox here, but it's critical. That people aren't asked to think. And we use a calculator to bypass it. So in any case, here we estimate a little less than half of the magnitude of A. So B. Let's say B is approximately 0.4. Again, B is a little less than a half because if I do this and then do this, it doesn't quite come up to this. I'd say it's about 0.4. Well, now we know the equation. Our conclusion is that y equals a times 0.4 to the x plus k, where a and k are easy to estimate. I don't have a scale on my y-axis, but if I did, I'd be able to estimate the value of y here and the value of k.